The overall conviction among most analysts is that the hypothesis of how things came to be remains the fundamental explanation for the early seasons of the universe. This speculation includes the evolution of stars, planets, and so forth, life on those planets, including ourselves. Not breaking through is a rather odd hypothesis named the Big Bang. It offers an illuminating examination of what could have occurred. At first, the universe was dense, compressed into a space smaller than a pinhead with particles packed tightly together. From this moment, a massive explosion of matter and energy occurred known as the Big Bang. This event, happening billions of years ago, set the stage for the unfolding of cosmic history. However, advancements in scientific data have triggered growing inconsistencies with the assumptions underlying this hypothesis. When NASA launched the James Webb Space Telescope, JWST, the largest and most advanced space science observatory ever, scientists speculated that its observations would confirm the hypothesis of the universe's origins. Unfortunately, after just a year in space, the telescope surprised specialists with its capacity to peer deeply into the universe's past. The James Webb Telescope's stunning capabilities have revealed countless galaxies dating back to such an ancient time that they challenge our understanding of the universe's beginnings. This discovery has ignited an intense investigation into what existed before the Big Bang. One key moment in this mission occurred when cosmologist Rohan Natu, working with data from the telescope, unexpectedly discovered a galaxy from just a short time after the Big Bang, making it the most distant system ever observed. NASA's discovery sent shockwaves through the scientific community, highlighting the incredible abilities of the JWST. Its primary goal to change our perspective on the universe has only just begun, promising to reveal astonishing insights into the earliest phases of the universe's existence. This previously unexamined period holds the key to understanding the formation of the first stars and structures. The telescope's discoveries have conflicted with initial hypotheses, uncovering galaxies with attributes exceeding past expectations. This flood of early galaxies has sparked a storm of scientific inquiry, challenging specialists to reconcile these discoveries with existing theories. As scientists grapple with these revelations, they face crucial questions about the very nature of the universe and the forces that shaped its evolution. Beyond the JWST's technological advancements, which remain consistent, it is located 1.5 million kilometers from Earth, safeguarded from ordinary interference, and cooled to nearly absolute zero by its tennis court-sized sunshield. The telescope features a massive segmented mirror and extraordinarily sensitive instruments designed to uncover details of the early universe previously hidden. This period, known as the Great Dawn, occurred several hundred million years after the Big Bang, marking the point when the first stars and galaxies began to form. The process by which this unfolded remains a subject of intense investigation, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the vast first light presents an extraordinary opportunity for cosmologists to test their understanding of these complex elements. By exploring these ancient systems, scientists can either confirm the validity of their current models or uncover gaps in understanding that could lead to crucial new discoveries. Initially, the telescope was expected to observe only a few faint and small galaxies in its pilot studies. However, reality has far exceeded these expectations. The JWST's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that challenged all forecasts. This shocking surge of early galaxies has triggered a race among space specialists to establish new records for the earliest known galaxies, with new revelations emerging regularly, leaving mainstream researchers in awe. Following the JWST's revelations, specialists and observers have rushed to study the presence of these shockingly advanced early worlds. Some theorized that errors in the telescope's interpretation of massive observations could be responsible for these unexpected discoveries. That said, the consensus remains that these revelations represent a shift in how we understand the early universe and provide exciting glimpses into the potential for cosmic evolution. The new discoveries from the JWST regarding galaxies have raised key questions about the nature of the universe and challenged the assumptions of standard cosmological models. While some researchers are investigating whether these observations can be reconciled with existing theories, others suggest that they might be the first signs that the universe is far more intricate and complex than previously imagined. The real question at stake is our basic understanding of how the universe emerged from primordial chaos. The early discoveries of the JWST could reshape our fundamental ideas of cosmic history, revealing insights not just about distant galaxies and ancient structures, but also about the very nature of our own Milky Way. The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, Garth Illingworth, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial doubts, he and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to see in the infrared spectrum, allowing it to peer much deeper into the universe. This capability is critical for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its enormous cold star-like mirror, the JWST became the premier instrument for unlocking the secrets of cosmic dawn. The need for the JWST became evident in 1995 when the Hubble Deep Field Observation revealed countless galaxies in what was thought to be an empty patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of probing much further into cosmic history. After 20 years of development and a cost of around $10 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most crucial year of scientific observations. Early efforts like the Early Science Program and the General Observer Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far surpassed them. The JWST's observations have tested existing models of the early universe, uncovering galaxies that defy conventional cosmological assumptions. These surprising revelations emphasize the importance of pushing the boundaries of scientific inquiry and highlight the remarkable capabilities of cutting-edge technologies like the James Webb Space Telescope. As specialists continue to explore JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began arriving, cosmologists eagerly awaited the results. Many had been preparing their data analysis pipelines for years. Instead of following the traditional peer review process, which typically takes months, researchers chose to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed for a new kind of peer review to occur through social media platforms like Twitter, where mainstream researchers could immediately discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of conversation was both extraordinary and overwhelming. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Mell, a JWST project researcher at STSCI, warned that while the quick sharing of results facilitates rapid discussion, there is also a risk of overwhelming the process. In the coming years, the JWST will continue to challenge preconceptions and expand the frontiers of scientific knowledge. As more galaxies are discovered, more data is collected, and more hypotheses are tested, our understanding of the universe will become increasingly refined. Ultimately, the James Webb Space Telescope promises to be one of the most significant scientific instruments in human history, offering profound insights into the universe's most fundamental questions.